Okay, so my name is Mary Bauer. I know most of you. I'm a 7th grade math teacher at Moscow Middle School, and I did my undergraduate at U of I. I did it in secondary ed for mathematics, and I'm currently finishing up my master's in curriculum and instruction. And today I'm going to be sharing with you my research and project on teaching fraction multiplication and division with an inquiry-based approach. So to start with my project, I did a literature review on the teaching and learning of fraction multiplication and division, and this provided me with a great starting point for the work that I do in my classroom. So before I share my project with you, I want to give you a little bit of a summary of my paper. So according to Tersch 2000, multiplication and division of fractions is one of the most mechanical and least understood topics in elementary school mathematics as well as middle school. The success rate with division problems alone is really, really low for students, and it's actually one topic where research, according to Park 2012, states that many teachers themselves actually struggle conceptually along with their students. There are several main misconceptions that the research credits for the student misunderstanding. First is that students have a very procedural-based knowledge of fraction multiplication and division. It's very rooted in an algorithm that has no meaning, and they lack a lot of conceptual understanding. Second of all is an overall misconception about the ideas of multiplication and division as a whole. According to Graeber and Campbell in 1993, the idea that multiplication grows your answer and division reduces your answer is actually one of the most notorious conceptions in mathematics as a whole. And then with this, students start to believe that fractions are a part of a different number system, that they have a whole different set of rules all on their own. And one other problem that Park 2000 also mentioned is that students treat fractions as a composition of two whole numbers rather than a single entity altogether. According to Sharp and Adams 2002, one of the best ways to teach fraction multiplication and division to prevent such misconceptions is to start with students exploring content through the real-world setting so that they can tie in what they already know about the real world, and then gradually move them towards symbols and algorithms. Yetkin and Caprano 2009 also suggest that we connect students' prior knowledge of multiplication and division to the instruction and then tweak it to include fractions. They also recommend making connections to proportional reasoning, which is going to be a huge thing with the Common Core standards and middle school mathematics. Despite the research on this topic, however, fraction multiplication and division instruction is not changing as fast as we would like to see in a lot of classrooms. According to research, one of the main reasons we aren't seeing changes is because teachers don't have the necessary tools they need to be able to make these changes. So a quote by Yetkin and Caprano 2009 says that conceptually based instruction of fractions requires teachers to have a complete understanding of the subject matter. Middle school mathematics teachers need both common and specialized knowledge of fractional concepts along with a general pedagogical knowledge. The problem with this, however, is that, as I mentioned before, a lot of pre-service and in-service teachers don't really understand the meanings behind the math themselves. A couple studies that I read were really interesting. One study by Armstrong and Bazook and Isaac 2010 had a group of middle school teachers, and they were given the problem 1/3 times 3/4. And when they were asked to compute it, all the teachers could compute it, but none of them could actually provide a model for why it worked or explain their thinking or reasoning behind the math. Another study described in Ball 1990 reported that when a group of 217 pre-service elementary school teachers and 35 pre-service secondary student or teachers were asked to show a visual for the problem 1 3/4 divided by a half, no elementary school teachers were able to provide a model, and only a few secondary teachers were able to do so. So, in order to fill such gaps in teacher understanding, the research suggests a couple things. One thing that Tersch 2000 recommends is an increase in pre-service and in-service teachers' understandings about the foundations of mathematics. Hello. And then Yetkin and Caprano also express a need for exposure to ideas, misconceptions, and thought processes of middle school students along the way. So in order to help fill this gap, I put together the following presentation on work that I did in my classroom. I'm going to be showing various strategies that my students came up with, different misconceptions that we saw along the way, and how I tweaked my instruction to fit that. And then I also have created an entire unit of lessons for teachers to use that have step-by-step instructions on how to take this to their classrooms. So it's a tool that they can use, and it's Common Core based and inquiry based as well. So my project took place in my classroom, like I said again, the 7th grade math classroom at Moscow Middle School, and this started in January 2013 and went through May 2013. So what I'm going to do now is kind of take you through a summary of the lessons that I did with my class. These have been tweaked since I've done them. I'm going to go over at the end kind of different misconceptions and why I had to change things around based on the results of assessments at the end and throughout. So to start off, I wanted to do an introduction with the students about thinking about fractions as operators. So this idea came from a book by Susan Lamont called Teaching Fractions and Ratios for Understanding. So we started with problems like this. I gave a bunch of problems. We started with 4 problems like this. So Sabrina is making the following batch of cookies for her friends. She left 1/6 of the batch at home and took 5/6 of the batch to school. How many cookies did she take to school? So students were asked to work on this problem in their groups. I told them they can start with a picture, they could use numbers, but they had to show what steps they took to solve this. And then after each problem, we'd come back as a class and I'd have the kids share their ideas, and some of them would be numeric, some of them visual, and we tried to connect, well, how does the picture connect to the numeric stuff? So at the end of the 3 to 4 problems, we went back and I had all the problems displayed on the board, and we were looking for patterns. What I wanted the students to specifically focus on was the role of the numerator of each fraction and then the role of the denominator. And when we were working through these, so the specific problem I had up there was 5/6 of 12. And a lot of students did 12 divided by 6, which was 2, and that was 1/6 of 12. And then they multiplied that answer by 5 to get 10, because that was 5/6 of 12. And so they said, well, the role of the denominator in these are our divisor, and the role of the numerator is the multiplier. Well, the problem with this is that students were seeing 5/6 as a composition of 2 whole numbers rather than being able to think of it as a combination operation of multiplication and division, 2 and 1. So I wanted to take them through a little string to help them kind of get an idea of what operation is actually going on. So I started with a problem like this, and I said, what does 3 of 4 look like? And they kind of look at me like, what are you talking about? And eventually, after a little bit, they realized 3 of 4 would be 3 groups of 4. So what is 3 groups of 4 as a math problem? Well, that's 3 times 4. Then I said, well, what would 2 of 5½ look like? And they eventually realized, well, 2 of 5½ would be 2 groups of 5½. So 2 times 5½. So then I asked, well, what would 5/6 of 12 be? And along this string, they were able to say, oh, 5/6 of 12, that's 5/6 times 12. Now this was just an introduction to this kind of stuff, which we ended up playing off of more in the next sections. So the next day, we focused more on this part of the whole idea. This is an expansion of the previous day. I wanted to start off, before even going to that day's lessons, on more exploring the meaning of multiplication, because from the research, students really had that idea that multiplication grows your answer, which isn't always going to be true, so I really wanted to focus on that. To do that, we started working on what question different multiplication problems ask. So I put this string up on the board and I did it one at a time. And I'd ask, well, what does 7 times 5 mean? And a lot of the kids would reply, oh, it's 35. Well, now that's what it equals, but what does 7 times 5 really mean? Well, it's 7 groups of 5. And what does 2½ times 5 mean? Well, that's 2½ groups of 5, and so on. So we're kind of going with this meaning, and I made this poster that I hung up in my classroom as a reference for them along the way. And you can see here that we have the first one. The question that 3 times 4 asks is, what is 3 groups of 4? And then I had the visual next to that. And then if you have 2/3 times 9, the question asks, what is 2/3 of a group of 9? And there were 2 different ways to show that, and we're going to look at this in the next slide. And then I actually ended up using this for expressions and equations later on too. And this is up in my classroom. It's really neat. My students are always looking back on the wall when I'm asking them, what question does this math problem ask? They can look on the board, and that's a reference for them. And it's been neat too, because we just started percentages today, and they're saying, oh, well, 15% of 20, hey, that's 15% of a group of 20. I must be multiplying. So that's kind of a neat thing there. So then we moved on to problems like this, where I read them the question and they had to write the math problem. So I'd say, what is 3 groups of 4? And they would write 3 times 4. I'd say, what is 5 groups of 3/4? And they would write 5 times 3/4. And these were strings that we did as a warm-up almost every day, either this or I'd give them the math problem and they'd have to tell me the question. So they're continually thinking about these problems. So that was a warm up for the day, and then we moved on to problems like this where we were finding part of a whole that didn't divide evenly. Students, I just put this up on the screen, they had to give me the question, so what is 3/5 of a group of 12? They had to give me an estimate, which is extremely powerful because the estimate so many times is going to be more accurate than their incorrect calculations of the problem. And then they had to give me their math problem based on the question, and they had the poster on the wall to help refer them to that. So I gave them this problem, kind of walked away, walked around to the different groups, and they were able to solve this in picture form. They were able to solve this however they came up with. Some common ways that students solve this were they took like 12 circles, and I won't draw them all, but they take all their 12 circles and they divide them into fifths, like this, and they'd circle every group of 3/5 and count up, well actually that's not right. They'd shade groups of 3/5, and they'd go through counting up and adding them all up, and they'd end up with 36/5. Another strategy that students came up with is they decided to take 3/5 of 10, because 10 is easily divided by 5, and so 3/5 of 10 gave you 6, and then they'd have the other 2 that they'd have to find 3/5 of. And this is an interesting thing too, because students really wanted to write that as decimals. So, but I told them that they had to write their remainders as fractions. So they're stuck with the problem, what is 3/5 of 2? And I'd start by, if students had problems, I'd say, well, what is 1/5 of, I would say, what is 3/5 of 1? And they could answer, well, 3/5 of 1 is 3/5. So what is 3/5 of 2? And they could use proportional reasoning to realize that that's going to be 6/5, or 1 1/5, which they would then add on to their 6 that they had found before. So that was kind of neat. Students were able to share their answers as a class, and it was neat to just watch kids change between different strategies depending on the problem. So the next day we moved on to taking a part of a part, and this students were given problems like this, and they were asked to draw a visual representation. So you have a problem, you have 3/4 of the pizza left. If you give a third of the leftovers to your brother, how much of the whole pizza is left? And sometimes I give them problems like how much of the whole pizza did he eat, which the visual that I have here that we interpreted that way. But this is 2 different ways to interpret this if you look at what part of the pizza that the brother ate. So you have the 3/4 that was there, and he's eating a third of them. So a third of a fourth, or a third of 3/4 is a fourth. Or I had students take the 3/4 and divide it in thirds this way, and look at your answer this way, which would be 3/12, which reduces down to a fourth. And we just spent a whole day going over picture problems like this. We didn't have homework at the end, I just wanted it to be an exploration day. And then the next day, we went on to more problems of fraction multiplication. So I started them off with a few more review problems like the pictures, and then I went into some strings, really focusing on the meaning behind the math and the algorithm. Because students with these they get into this really fast and say, oh, this is super easy. If I take, a third of a fourth, and they draw their picture, and they have their fourth here, and then they circle and they say, well, this is a third of it, that's a 12th, and they really quickly start saying, oh, I just multiply straight across, but then they forget, what's really going on. So I built this string to kind of help them, and I start with a problem like this, what is 1/5 of a third? And I ask them to either visualize this in their head or to draw a picture, and they say, well, a 15th. Okay, so if 1/5 of a third is a 15th, what's 1/5 of 2/3? Well, that would be 2/15. And then what would 1/5 of 3/3 be? Well, that would be 3/15, or a fifth, because it's the whole thing. And then we went on to other ones. Well, what's 1/4 of 2/5? 1/4 of 3/5, and all this kind of stuff, starting from the unit fraction of 1/4 of a fifth, and so on. So the next day we moved on to multiplying mixed numbers. One of the main problems that I had seen with multiplying mixed numbers in the past is that students like to multiply the whole numbers and then multiply the fractions and then add them together. They don't really think about what's actually going on. So to prevent this, I started off this with a lot of estimation, and I gave students problems like 2.5 times 11, give me your estimate for this, and then solve. And they know what they're doing if they are estimating stuff, so we didn't really have to go over how do I multiply a half by 11. They just were able to think about that. And they had to check their answers with their neighbors, and there were kids that did do 2 times 11 and add on a half, but their neighbors are pretty nice to say, no, you're completely wrong, and then they correct all that kind of this stuff. So Once we did that, I put up this slide on the screen because I did want to talk about the misconception with them. So I said a student last year was given the following problem: 4 3/4 times 8, and they said the answer was 32 3/4. Is this correct? Why or why not? So students were able to explore the misconception, and students who had maybe made these estimation mistakes during the estimation time were able to see that without getting embarrassed in front of the class. After that, I wanted to move on to multiplying mixed numbers by mixed numbers, and I wanted to start this off with a string that kind of that made an estimate. That put two endpoints on my problem here to help them estimate. So we started with 2.5 groups of 7, and then 2.5 groups of 8, and then I gave them this problem. And I said, well, why am I giving you these two problems? And the students will say, oh, well, it needs to fit between those. And interesting enough, with this problem, it should fit exactly between there, because I did 2.5 times 7.5, and it was kind of interesting because I could play with, well, it wasn't always going to be in the middle, but I started with problems like this that would force students to really think about what they're doing. And if they did do 2 times 7.5 times a half, they would realize their answer didn't fit in there. Something was wrong, and they were able to kind of work through that. And I did want to go over the misconceptions with them, so I gave them a problem like this. James and Lily were given the following problem: 3.5 times 3/4. James said the answer was 3 3/8, or 27/8, and Lily said James was crazy, and the answer was 2 5/8, or 21/8. Who was correct? What did the person who was wrong do? And start by making an estimate. So I gave them that, and they had to talk about those in their groups. So then we moved on to a second day of fraction multiplication. And for this, I wanted to work students towards using the improper fraction version of things, because that's a lot more efficient way to do things. So to do that, I started them with a string like this. I said, what is 1/4 of a 1/6? And they should be able to say 1/24. Well, what's 3/4 of a 6? Well, that'd be 3/24. And then I gave them the problem, what is 2 3/4 of a 6? This made them have to think about how many fourths they had to be able to continue down this string. So it forced them to turn it into an improper fraction to be able to solve this. And then they could use this answer to figure this one out, forcing them to do that. And so we did multiple ones of these. I also wanted to tie in the visual for this kind of a problem. So I went back to the arrays that we had done before. So I gave them a review problem here that was just a fraction of a fraction, and then I had them do a problem like this. You and your friends eat 2/3 of the 1.5 pies you find hidden in the fridge. How many whole pies did you guys eat? So I had them go through those pictures. We shared our answers as a class. And then at the very end of that lesson, I gave them this problem. Your brother ate 3/4 of a 2.5-foot roll of tape gum in one afternoon. How many feet of gum did he eat? And then I said, you ate 2.5 strips of gum that were each 3/4 of a foot long. How many feet of tape gum did you eat? So I gave the students, I said, you can solve this any way you want. You can use multiplying mixed numbers. You can just use the improper fraction version of it. You can draw arrays, whatever you want to do with that. And I wanted them also to compare these two answers so they could see this really will give you the same answer. So I have a little video of this in my classroom, and it was really neat. I had a kid that did all 3 methods in one. So. Okay, you got 15 18. Yeah. Where is your 2.5?
That's right. I did 1, 2,
okay, sounds good. And then when you're looking at the 8s, where do you look to name the piece? How did you know it was an 8?
I counted the amount of pieces that were in 1.
Okay, perfect. Sweet. So what's the math problem for this one?
3/4 times 2.5.
Yep. Okay, now my other challenge to you is I want to figure out how I just use the numbers. Can you use just the numbers to get 15 8s?
Yeah.
How could you do that?
Well, I would. First, it would be easier if I just converted this to 5. So, I'll keep that in mind. Then I'll just do
You change that to 5 halves.
1/2
1/4 times 1/2. Okay.
equals 1/8.
Yep.
Then 3/4 times 1/2. Multiply this by 3.
Yep.
So 3/8.
So 3/8, okay.
Then 3/4 times 5.
is there any way you could have gone straight from this to this answer? You built it through this, showing me that you totally understand that. Could you have gone straight from here to this answer?
Yeah.
How?
I would just do all this at once.
Yeah. Cool. That's awesome, Brady. You got it. So here is an example of his work here. So I thought that was kind of interesting way of explaining things that we could look at later. So from the fraction multiplication, we moved on to fraction division, which is every teacher's worst nightmare. I was excited for it. So we started off this section. I knew that we needed to address what the meaning of division was, because that was the root of all of this kind of an issue. So I started with the problem. I asked students to draw a picture of what 8 divided by 2 meant. And there were 2 different ways that students might be approaching this. And I walked around the room kind of looking at the different ways students did this, and I had them put up their answers on the screen, and we were able to look at the 2 questions that they had. And I have this poster that I made here, and I used the problem 10 divided by 2 on this picture here, so if I walk over here. You can see the 2 different questions that they can come up with. So 10 divided by 2, we have 10 circles, and the first question would be how many groups of 2 are in 10, and so there's 5 groups of 2 in 10. Or the other question is if I split 10 into 2 equal groups, what's in each group, and it's going to be 5. So I started there. And I made this poster, and as we went on to more and more different fraction problems, I added onto the poster so that they could have that as a reference point. And again, when I did the math problems, I'd give them questions like, or how many groups of 7 are in 9? And they'd have to write the math problem, and so they'd be able to look at the poster as a reference for that. So for the first day, I told them that we'd be working on the question, what's in one group if I split my whole into a certain amount of pieces. Students were given this problem here, to work on a fraction divided by a whole. So Mrs. Johnson brings Skittles to be shared equally by members of groups winning games at the school carnival. How many pounds of Skittles will each student get in the given situation? Include a visual, circle your answer in your pictures. So these were the 3 different situations. 4 students sharing a half a pound of Skittles, 3 students sharing a quarter of a pound of Skittles, and 2 students sharing a fifth of a pound of Skittles. And the students drew pictures like this. So for the first problem, we had a half a pound of Skittles right here, and they had to divide it by 4, and they had to say what each student got. And there was a lot of misconceptions at the beginning. They said, oh, they got a fourth. Well, it's really not a fourth, that's a fourth of a half. Well, what's a fourth of a half? And it's an eighth. So really kind of working through those things there. I later asked them to write what the math problem was for this, and some students were saying a half divided by 4, and a couple students were able to say that we are taking a fourth of a half, and they knew this because we had done a lot of the fraction multiplication using arrays, so they were able to make those connections. So that day we went through several problems like this. We even had some mixed number ones as well. The next day we began our exploration of a whole number divided by a fraction. That day I wanted to address another misconception that I had seen with students where they mix up the order of division problems. And so I asked them these 2 questions, and I asked them to write the question that each of these asks. So 12 divided by 3 and 9 divided by 15. And the 2 questions that they could have said for the first one are how many groups of 3 are in 12? Or if I take 12 and split it into 3 equal groups, what's in each group? Same thing for this kind of a problem. And what we did for all of those, that I said, well, what is the role of the first number in that problem? And the first number in the problem was always the whole, and the second number in the problem was always either how we're dividing up the whole or what's in each group when we divide the whole into equal groups. So I put that up on the board for a couple days just to really get the kids to understand the first number in your division problem is always your whole. So we moved on to problems like this for our first day of exploration of whole divided by fraction. This problem is actually taken directly from the MTI course. The problem says, Lauren ordered 4 yards of dirt for her raised flower gardens. Each garden needed 3/4 of a yard of dirt. How many gardens can she fill, including partial gardens, and how much dirt does she have left? So for this, students had to draw pictures. Students usually drew 4 big squares, and they had to divide them up into groups of 3/4. I asked them later to write the division or write the math problem for this, and they were able to look at the poster and say, well, what question is this asking? It's asking how many groups of 3/4 are in 4. So the math problem is 4 divided by 3/4. Students had to struggle with leftovers. There's leftover pieces of this garden, and they had to figure out, well, this leftover, is this a leftover part of dirt, or is this a leftover part of a garden? and 1/4 of a yard of dirt is how much of a garden, and so on. So we explored a bunch of problems like this the first day. And then the second day, we moved on to more exploration with fraction divided, or a whole divided by a fraction. Today, I wanted students to be able to, by the end of the day, start working through strings to maybe get to seeing a little bit of the patterns working towards the algorithm. So this first problem given here, the Easy Baking Company makes muffins of various sizes. There are 20 cups of flour in one of the packages they buy. How many muffins can be made from a package of flour if each recipe takes the following amount? Support your answer with a ratio table or picture. So this is an interesting problem. I gave them to the class. I told them that they could work in groups of 2 or by themselves, and just kind of let them go and play with it. And here's a little video of what a couple students did in my class.
Idea for
the first one? I drew like all of the little cups of
Okay, sounds good.
and then I was doing the ratio table.
Okay, can I see your table? What are you going to put in your table?
Okay, so I was going to put the 6,
Okay,
and then I was going to figure out what 1/6
see what Raymond's thinking here. So, look what she's got here. She's got, well, actually, Lydia, why don't you go ahead and explain what you've got?
Okay, so this is what the problem will look like, but that's how it comes to flour. And then that's flour, that's the muffins, and for the apple muffins you have 1/6. And then that 1/6 makes 1 muffin, and then you try to figure out what 20 cups will make.
So, are you okay with what she set up there?
I think so, but
Okay.
she could probably, you find out 10, probably.
10 what?
Yeah. 10 muffins. Well, 12.
10 muffins?
Well, I think 12 would kind of, no, not really 12, but I was thinking 12 because that would have been 2 muffins.
12 muffins would have been 2 what?
Well, 2 cups of flour.
Okay, so put that on your table. Awesome. So Lydia, if you know that 12 muffins is 2 cups of flour. Okay.
And then I could figure out 18.
You can figure out, do you have ideas now?
I'm just about to say, if you times this by 2, by 10, because 10 times 2 is 20.
Okay.
I'll just take there.
Okay.
Wait, is it equal still? 10, and that'd be 120.
Okay. So 20 cups of flour and 120 muffins?
Yeah.
So we got it?
Okay, so in case you didn't follow that, 1 cup of flour made 6 muffins because I said that each muffin takes 1/6 of a cup of flour for this particular one. And then the kid figured out, well, if 1 cup of flour is 6 muffins, that if I have 20 cups of flour, then I can multiply by 20, and I can find out that I have 120 muffins from there. So the interesting thing with this problem was that when we got down to the bran muffins, students started to have problems because they were going to say, well, man, how am I going to figure out how many bran muffins this can make if I have to do 20 divided by 3/4? So I don't know if you heard some of the girls in the background going, oh. What they were figuring out was that if they had the answer to the blueberry muffin, so we know that if 20 divided by 1/4 is going to be 80 muffins, that if we had the problem 20 divided by 3/4, a lot of the students thought, well, I just take 80 and multiply it by 3. Well, what was really interesting walking around when students were having problems with that, and students were correcting each other, they said, well, I asked them, I was like, well, what are you going to have more of? Are you going to be able to have more bran muffins, or are you going to be able to have more blueberry muffins? And they said, well, we're going to be able to have more blueberry muffins. Well, why? Well, because it requires less flour. Okay, well, how many times more blueberry muffins will you have than bran? And they said, well, 3 times more. And then I just kind of walked away. And then you wait a couple seconds here. Oh! And so they would take this and divide it by 3. And then again, the kids would want to find the decimals, and they'd be stuck and say, well, what's 1 divided by 3? And they'd have to draw their picture, and they'd say, oh, that's 1/3. So then what would 80 divided by 3 be? Well, that's 80 thirds. And then they were able to take that and turn it into a mixed number. So I really liked this strategy at first, and this is the strategy I was going to use to help build strings for fraction, whole number divided by fractions, and taking problems like, well, if I have 5 divided by 1/4, they can figure out that this is going to be 20. So 5 divided by 3/4 is just going to be this number divided by 3. This worked, except it ended up becoming kind of complex and kind of messy with all this kind of stuff. And a student of mine actually changed how I approached this completely. He came up with a solution to a problem that I gave him like this. And he said, well, I know that 3/4 fits into 1 1 times, or 4/3 of a time. So if 3/4 fits into 1/4 of the time, to figure out how many times it fits into 5, all I have to do is take 4/3 and multiply it by 5. And it took me going home that night and like laying in bed figuring out, what is that kid doing? Oh my gosh, he just figured out the algorithm for flipping and multiplying. This is amazing. So I scrapped all my lessons for the next day and rewrote them to fill in with Isaac's method. So I have adapted these lessons to include, like I had already used Isaac's method before. So I gave students problems like this. So you have a quart of fruit punch in the fridge. If you pour 2/3 of a quart into each glass, how many glasses can you fill? I asked students to write the math problem for this and to solve it. They had to draw pictures for most of them for a little while to figure out that if I have 1 cup and I'm trying to figure out how many times 2/3 can fit into this, that this is 1 serving of 2/3, and then this remaining piece is a half of another serving. So this would be 1.5 servings, or 3/2 of a serving. And these are the kind of problems that the Marne Gardens problem initially had explored with them, so they had some practice using pictures and finding out what the remaining pieces were. And then I asked them to use that answer, so if we knew that 1 divided by 2/3 was 3/2, then I'd ask them, well, how are we going to figure out this problem? How can we use this problem to figure out this one? And they said, well, we can just do 3/2 times 4. So then again, thinking proportionally and pulling that in. Here are a couple picture examples of this. I just kind of did a couple examples here already. So 1 divided by 2/3. 2/3 fits into 1 1.5 times. If you have the problem over there, 4 divided by 2/3, you can see that 2/3 fits into 4 6 whole times. And then we went through strings like this, building more. So before I moved on to the last section, I wanted to give students a little bit of a break because I found that they still need repetition. They still need practice. So we moved on to a couple different fraction division problems that involved ratio tables. And these are problems that I didn't initially think of as being fraction division. So problems like if it takes you 3/4 of an hour to travel 4/5 of a mile, how long will it take you to travel a full mile? Which to us don't really seem like a fraction division problem, but they are. So to start this off, I wanted to get students thinking about this kind of process. We started with some visual problems like this, and I said displayed to the left is 3/4. How many squares make up the whole? How many squares make up 1 1/4? How many squares make up 3 3/8? Went through problems like this. Another problem like this that I found from a book, that is 2/3, find 5/6, or 1 5/6. So they had to be able to break this up to find out what 1/3 is. So if that's 2/3, I split it in half, I get 1/3. And once I know a third, I can build 3/3 to make the whole. And once I have the whole, then I can divide it to find a 1/6, and then I can find 1 5/6. So kind of a fun process, and the kids love these. They're actually pretty good at this. I had another one here, the area in blue. Okay, these both look blue, but this was the blue part here, represents 2/5. Draw the whole. So they'd have to be able to partition it and divide that up. And then we got to problems like this. You were staining your deck. You find that 3/4 of a can of stain will cover 3/7 of the deck. How much stain do you need to cover your full deck? So I gave students problems like this. I said, figure this out, solve it any way you want. They had had a lot of experience with the ratio tables, so any students that had problems said, hey, can you set this up in a table? Some kids just went there on their own. And I had a couple kids that drew pictures and were able to split it up with pictures. That was totally not how I was visualizing this one, and it was really neat to work through that with them. So the ratio table version of this one looks like this. So you have 3/4 of a can of stain, and that covers 3/7 of a deck. And you want to know how much your full deck is, so you want to solve for 7/7. So it's easiest to go from 3/7 to 1/7 by dividing by 3. And then we have 3/4 divided by 3 again. So that is practicing more fraction division stuff right there, and that's 3/12. And if we know 1/7 of a deck is 3/12 of a can of stain, we can multiply that by 7 to find are whole or 2 full cans of paint, because you can't buy a part of a can of paint. The kids are really good at telling you that. So those are kind of fun problems that we moved through. And then I took a whole day of just reviewing more problems, because again, we've spent so much time in the past drilling and killing problems because kids don't get it. Well, we don't need to drill and kill, but they still need extra practice, and they still need to see more things. And then at the end of this review day, I did a little quiz so that my warm-up questions for the next several days could be based on the problems that they still had issues with. The last section that we did was a fraction division, was fraction divided by a fraction, and this was still based off of these kind of problems here. I started kids with this problem here. So Sarah is really obsessed with nutrition and checks serving sizes on everything. She has several boxes of cereal on top of her fridge and is trying to figure out how many servings of each she has left so she knows when to buy more. I had a kid, I gave this to them today, so I was like, hey, I do that. Crazy. So I gave them the problem here. One box has a cup of cornflakes left. How many 3/4 cup servings can she make? I asked the students to give me the math problem and then the solution. And I asked them, I think, well, what is this question asking? And so once they figured out the question was asking how many groups of 3/4 are in one, they were able to write the problem 1 divided by 3/4. And then based on their work from the last week or so, they were able to say that this is 1 1/3 or 4/3. And a lot of students were jumping straight to 4/3 at this point, which was kind of cool. Then I gave them problems like, that's in the wrong spot. One box has a 1/2 cup of cornflakes. How many 3/4 cup servings can she make? So this led to the problem 1/2 divided by 3/4. And then I asked the students, how is this answer going to relate to this answer? And they said it's 1/2 of it. Well, how can we find 1/2 of this? Well, we can divide it by 2. Well, how else can we find 1/2 of a group of something? So pulling in multiplication once again, we can find 1/2 of a group of this by doing 4/3 times 1/2. And then moving on to our next one, one box has 1/4 cup of granola. How many 3/4 cup servings can she make? So this led to the problem 1/4 divided by 3/4. Then going back up to our original again, how is this answer going to relate to this one? Well, it's going to be 1/4 of it. How do we find 1/4 of a group of something? And sometimes kids were not quite getting that, so I said, well, what would the math problem be for 1/4 of a group of 10? So we go back, well, 1/4 of a group of 10. Okay, and so we'd move back onto this. Well, how do I take 1/4 of a group of 4/3? Well, 4/3 times 1/4. And we were able to move through this and so on. So this is a string that I did. This is really neat because if you look at this initially, it looks like all these kids are doing is flipping and multiplying. But what I did with this string is I gave them this problem. How many groups of 4/7 are in one? And they were able to say 7/4. And then I said, well, this problem here, how is this going to relate to this problem here? It's going to be 1/5 of that answer. So what math problem can you do to solve that? Well, I can take 1/5 of 7/4, which is 7/20. And then moving on to this problem, well, how is this problem going to relate to this problem? This one's going to be 3/4 of the answer of the first one. So what math problem can I use? 3/4 times 7/4. And so we went through this, which is really neat because when you step back, the kids are like, oh, you're just flipping and multiplying. But they're really using proportional reasoning to think through this. And they're understanding what's going on, and they always have something to fall back on if they forget what they're doing. So that was pretty much that. Different things that I added in. Assignments each day, I made sure that I made my own worksheets, and they were always including reviews from the previous day, so there's always a problem about fraction multiplication, even on the division ones, because as you can see, it's super important that they're still understanding fraction multiplication along the way. I'm always using word problems in my stories. They always start through that because, like the research has shown, you have to tie it to real world meaning, and then eventually reducing it down till they were just problems that I hoped that they would build a string for. I was doing quizzes along the way also so that I could see where students were struggling, and that was pretty much that. I'm still working on fraction division with my kids right now. This started in January, and we are still doing strings like this. This has taken a long time, so what I learned was we were able to take our fractions test on addition and all that kind of stuff, but once we got to fraction multiplication and division, that took another month, and we had to just keep doing warm-up problems every day. I'd go back to it, I'd take a break, go back to it, and then just last week we did another quiz. I stuck it onto their geometry test, and they did so much better than they had when I initially gave them the fraction division and multiplication test. And so I think one thing that I learned is that you don't have to test at the end of that section. You can take the test 2 months down the road if they really still need that extra time. So that is that. Does anybody have any questions?
So you said that you made this plan and used the plan, but then you have some ideas about what you would do differently.
Oh, yeah.
Have you presented just what you
So this is
actually did?
this is what I would have done differently. I forgot, I should mention some last time. So one of the big problems I ran into was that kids were really ready they found the rules too fast, and with fraction multiplication, they still had that misconception about fraction makes bigger. And so the posters are something I actually created after I had done everything, because I still had problems where kids were doing 2/3 times 11 equals 22. Because they were just doing 2 times 11, and they weren't understanding that. And I also had them, I was allowing them to say, well, 11 groups of 2/3, so that's 22/3. And I was letting them leave their answer like this, which to a student still looks bigger than 11, because they see that 22, so they're not really seeing that I got smaller. So I went back and said, well, we need to start estimating more, and you need to write your answers as mixed numbers. I thought that they were in 7th grade old enough to be able to leave them as improper fractions and be fine, but they're not, because they're still thinking that this is a bigger answer. And so that was one thing that I had to go back and readdress as well. I'm still having students want to, if we are making a problem smaller, that they want to be dividing instead of doing this kind of thing. Same thing with the multiplication. They're wanting to, like the reverse kind of thing. But it was interesting today, it's been really neat. We started fractions and percentages, like I said. And it was really neat. The kids were saying, I gave them a problem like find 20% or 15% of 20 dollars or whatever. And so I had some students saying, well, I just did this, and I wasn't exactly sure why I did that, but it just felt right. And I said, we worked through it, and they're like, well, yeah, I'm taking 15/100ths of 20, and that's multiplication, and that's 15/100ths, so it is multiplication. And there were some kids that still wanted to do 20 divided by 0.15 because they were getting smaller. And it was neat, though, as I was talking to some students, we talked about this as a class. I was like, well, why is this not right, once they all figured out that this was a better solution? They said, well, if you do that, you're going to get a way bigger number. And so they're finally starting to realize the connections. And so it's definitely been paying off. But the going through and doing the questions every day, asking them to say what the question the math problem asks, and being able to write the math problem if I give them the question, it's been a huge thing. They're so tired of it now. But I'm hoping that they're probably not going to remember everything over the summer, but next year when they do get to 8th grade math and they're being told algorithms, that they at least remember, oh my gosh, we did so much of this and we figured all these patterns out with the string, so I'm fine, I believe that this works, and they're going to be able to hold on to it a lot better that way. So.
Sounds like they also have ways to figure it out on their own if they didn't hold on to it.
Yeah. So, it's not perfect, but it's a lot better than it was last year. So.
It's really exciting work. Well, and ideally, we would have teachers of younger students using many of these methods too, and once that happened, then 7th grade wouldn't have to spend so much time on this.
Yeah.
6th grade too.
Yeah. Like if you spent all the time just doing the exploratory picture stuff, then I could apply it, like it'd be super easy.
That was kind of part of my question. What gave you the idea to go after it with a strand, I guess, approach rather than the picture?
So in the previous years we had done so many picture stuff, and I said, okay, look at this, see the pattern? Okay, let's use the rule now, because you can't use a picture forever. But then the kids didn't really see a connection, and so getting the strands, and really the one student who showed me his method of thinking, well, 3/4 fits into 1, 4/3 at a time, how many times will fit into 5? I was like, oh my gosh, that's brilliant. And so I used his idea and thought, well, that was a strand, I can take this, tweak this, and apply this to all the other sections. And then really realizing that there were 2 different types of division questions. That's what got me before.
Yeah, that's what
was that, like, what do these mean? This doesn't mean 1 split into 3/4. There has to be another way of thinking of something. And a lot of the research that I read was that students are taught that division is splitting. It's always that kind of thought process. And so when they get to these, they're like, I don't know what I'm doing. And so really thinking, okay, how many groups of 3/4 are in 1? So.
That was actually what I was going to also ask is, can I please look at your poster again? So
Yes. And I have all of this stuff, I can give you guys these slideshows too. And I have the full...
Because I love how you worded the 2 different ways to phrase it. What's in a group and how many groups, or how many?
Yeah.
So,
And the other mistake too I made was I just let the kids tell me what's in a group or how many groups, and then they got lazy. I'm like, okay, we're still not understanding this. No, you have to say the entire question. If I split a third into 3 groups, what's in a group? Because they were still, and then this, once they know the question, this tells them how to solve it. You can literally say, split a third into 3 groups, look in one group, you're done. So, that kind of a thought process. But I have all of my complete lessons with everything from how to write your homework assignments and everything pre-typed that's spent lots of time on. If you would like a copy of it and you guys want to write your email address down, I have all of that. So I can share my Dropbox folder with you. If that doesn't work, let me know and I can.
You can just send it right to me.
Sounds good. But
I'm just gonna write my name.
Yeah.
I just know by my email. So you had the one that was 9 divided by 15. How many of your kids would? You can't do that.
yeah.
Yeah, I get that a lot. You can't do that. Really?
And then I always go back to, well, what's 1 divided by 15? Because if you can always take them down to the unit of anything, they're able to build up and see that. So, and it's been neat because my kids write things, their remainders as fractions now instead of repeating decimals, which is like, oh, thank you. So, and it was so neat today. I had a kid when we were doing ratio tables for fraction percentage stuff. I had a kid and he was trying to find out what 15 multiplied by to get to 100, and he's like, well, 15 times 3 is, 15 times 6 is 90, so then I've got 10 left over, and 10 is 2/3 of 15, so 15 times 6 and 2/3. I was like, where did you come from? Like, these really cool things are starting to happen as a result of them thinking this way. So, and I had started the year off with exploring what multiplication meant, what division meant a little bit. I'm doing partial division with them, so if you're doing 13 divided by 3, that they would do 9 divided by 3, and then look at the remainder and write that as that kind of stuff. So they were a little bit used to this kind of thinking process. But yeah.
So your kids love math class?
I think that they're a little bored of me questioning at this point. They're like, we get it. Like, not really. So, but yeah, no, they do, and it's really fun to watch them explore and question and listen to them talk with each other too. I love it. So
Great project.
And they work hard, but they have fun doing it.
yes, and she's in my class too,
Your class.
so she
Every
gets
day.
to witness.
That's cool.
all that kind of stuff.
It's been
But-
a huge journey from
Yeah.
day one to now.
Oh yeah, I've changed so
Huge.
much. So, yep.
Did you find that you had to make quite a few changes after formative assessment to try to keep them on the right road?
The main changes that I made were, like, I had to make all these posters, and I had to start asking them the questions. And one day we actually just had a whiteboard thing for 20 minutes, and I'd read a question, I'd have them write the math problem, I'd hold it up, and I'd be able to say, yep, you're good. And then I'd be able to see which kids weren't getting that. And so those are the kind of things that I made, and then I said, okay, you all really sucked on your fraction multiplication division test. I need to redo this, and we can come back to this later. And so continually bringing that in. It's not ever going to be perfect, but it is a lot better, and I'm a lot more happy with things now, especially because the main problem kids were having was the part of a whole. So if I said you have 17 cans of soup and 2/3 of them are corn, how many cans of soup are corn? They always want to do 17 divided by 2/3. That was a consistent thing because we're getting smaller, and so really working with them on that, it was so much better. This last test that we took, I'd say 80%, 90% of the students got that math problem right. And I asked them, they had to provide the question, they had to provide an estimate, they had to provide a math problem, they had to provide a solution. I don't want just the solution, because you can accidentally get that right, and I don't know what you're thinking. So, and I do all partial grading on stuff, so I can really see, and it takes hours to grade things. But I can really see what's going on, and I know where they need changes and all that kind of stuff.
So it sounds like every day is formative assessment.
Yeah.
Yes.
But the reason why I mentioned is you can go down the wrong path and take literally days or weeks to get them
Yeah.
back on the right road.
Yeah. Well, I'll say this. If I went back next year and used my lessons, this would probably take half as long as I thought, because there were things like, oh man, if we had talked more about the meaning of division on this, we wouldn't have had this issue. So a lot of it is exploring that stuff along the way. So I'm excited to use this next year. So it's like, yes, finally I know exactly what I'm doing. So.
Well, and I love that you brought in the meaning of multiplication division, because a lot of teachers and very few curricula just don't do that. They don't know that it's important, and so kids don't have anything to connect it to.
Yeah. Well, and I didn't even realize that was an issue until the misconceptions that students started making. I was like, oh my gosh, you don't even understand what division is. And so to be able to think through that was really important. So, yep. Oh, and I had a guy today, this is crazy. He took 15% of 55 today by doing 15 hundredths times 55 as 100, and he reduced this down to fractions, operated the entire thing on fractions, and got 8.25 out of 100, because this is like $55, and said that your tip for that day was $8.25. And I was like, you have got to be kidding me. Like, this is incredible that he was able to treat it like that. And he reduced these down, multiplied them, and all this kind of stuff, and then took the answer and multiplied it to make it out of 100 again, so that he could find that and say that that was his answer.
I need to tip more than 50%.
But it was crazy. I was just like, are you kidding me? So it's really neat, the things that are happening as a result of this.
So not only have you helped them think about multiplication division, but you've just trained them as thinkers mathematically.
Yeah.
That's what every kid needs.
It fits really well with what little I've seen of the math, because I haven't avoided it
Yeah.
a lot. But of the smarter balance pieces, I mean, that's, you know,
Good.
they're gonna have to be able to do that. So
Yeah.
They are.
And it really fits well.
Yeah. It's just hard, like teachers need stuff, because it's hard to make this all on your own. So, it's a lot of work.
It is, and it's not in the textbooks yet. They'll tell
Actually,
you it is,
Connected
but
Math, I stole a couple of the stuff from that textbook. It has some good stuff to
Yeah, they
start
do.
with. But, yeah. So.
Well, in your spare time, you just need to read a textbook then.
Yeah, I know.
Actually, already.
Seriously, I know.
At least
You
one.
got part of it started.
I know. My husband's like, please no. So,
Great
Yep.
job, Mary.
Yeah, great job.